the co-chairs of the South Bay chapter of Baynet, along with Joe Cazarza back there, and Theo.
Nobody can pronounce my name, so don't worry.
As long as you know Theo.
You can't even pronounce it.
I can.
Good evening. So how many of you have met, is this your first Baynet meeting? Welcome. Baynet is a local group of .NET user group here in the Bay Area. We have a number of chapters and about 1,000 members in open event day. We have monthly events, technical meetings, business and working groups. We have 4 sub-chapters, which have a monthly, each chapter tends to have monthly evening meetings, free and open in attendance. We have the one chapter here in the South Bay chapter. We meet in the Mountain View, Sunnyvale, San Jose area. There's a chapter that meets in San Francisco itself. A chapter that meets over in the East Bay that's now was in Pleasant, is now in Berkeley, and a currently defunct North Bay chapter, which is trying to get itself revived. It's looking for a venues. So our night tonight, we can thank Duval and iDesign for giving us making arrangements for having this facility to be used tonight, and also for Marty to come and give us this presentation on all his work he's been doing. Okay, so I said the East Bay chapter meets at City College in Berkeley on the second Tuesday of the month. They have not yet posted their topic for this coming month. They meet in, as all of our chapters, we use Meetup as our communication media, so if you want to check that, Meetup, Baynet group on Meetup. San Francisco chapter, or the North Bay chapter, I said, is looking for new. If you know anybody in the Marin County or North Bay area that knows of a meeting facility that would be available at a minimal cost, that's what's keeping them from reactivating at the moment. The San Francisco chapter is meeting at the Zero offices. It's not on Market Street anymore. It's full side. We meet the third Wednesday of the month, which will be August 23rd. They have not yet posted their copy. Our next meeting here in the South Bay is tentatively scheduled, will be for the end of as our normal meeting time is the last Wednesday of the month. It will be on August 27th. Oracle has tentatively offered to give us hosting facilities on their campus and give us a presentation on their .NET interfaces. Coming up, a big event here for those of you in Silicon Valley who haven't known about it, it's the Silicon Valley Code Camps. The full weekend, Saturday and Sunday, held on the Foothill College campus. All the topics, not just .NET, but Java, HTML5s, all the technologies. The full session, about 800, 900 sessions over the 2 days. If you want to know more about it, the URL is siliconvalleycodecamp.com. It's a great event. Your co-chair here will be giving this year will be his topic. You see my red shirt from previous speaker Ed will be speaking on building custom maps using Google Maps and Bing Maps. That's going to be my topic for this year.
just out of interest, who has been at the Silicon Valley Code Camp? Who has been? Okay. I can only recommend it. It will have more than 3,000 attendees this year for sure, and it's roughly 220 to 250 sessions with many professionals and speakers who just do it for fun. So you have a great mixture on topics, what you can see, and who you can engage with. And it's a great way to connect to new people and get to know new stuff.
Also some really good tracks for your kids, so bring them too.
That's true.
I'll second that actually, because I'm from Philadelphia, so I'm active in my local .NET users group, and those guys run a camp every year, and camp is fantastic. So if you haven't been, check it out, because it's a lot. They're great networking, like you said, and you learn a whole bunch of stuff. So.
And it's free.
Yes.
It's free. Even your pizza and your lunch drinks are free.
Yeah, you can't get any better conference.
No.
.NET and the Bay Area Youth Groups also sponsor small working groups to coordinate that when somebody gets together and in an next area, a special topic, we help facilitate that. Right now we don't have any active working groups, but are interested in organizing such sessions, and that contact one of the three of us, and we will assist in making facilities available to help you get you set up for that. In addition to our monthly meetings, we have on roughly quarterly a full Saturday, what we call education days, which are deep dive in a specific topic. We do charge a nominal fee for these to help compensate for the speakers we bring in, and also for our costs, and also give some of the money to keep us going. Although we are a volunteer organization, we do have some costs, so that helps that. Finally, we must thank our sponsors, including particularly tonight IDesign.
While we wait, I think let's give our sponsor a little hand, because without the sponsors, users groups would barely be possible. And it also allows us to get speakers from outside who fly in, and it's really appreciated. So.
And in the .NET community, there are a few other pieces around besides Baynet in the area. There's INETA, which is an international organization of .NET user groups throughout the world, and that's where you can find. They provide some speaker support, and that's where if you're in another area and you want to find out what the user groups are, www.ineta.org lists those. For you who have high interest in database, there's also a very active database users group in the Bay Area called BAD. They're database developers. They have two sets of meetings. They have a group meeting, a sub-chapter meets in San Francisco, and one that meets down here in the South Bay, where you have more things. There's a very active hacker dojo here in Mountain View.
Faster slides.
And then if I have to change my promotion. As we said, it's a volunteer organization. The three of us try to keep this chapter going, but we couldn't use much help. Particularly, the thing we need is that if any of you are local organizations and your organization could provide us with meeting facilities. We have not had a couple of months for meetings because we have not had a venue. Fortunately, IDesign is putting the cost for this facility for tonight. We had a good we're getting good going with Nokia in Sunnyvale until they got acquired and moved. So we are looking for a new home to have meetings again. So if any of you work for organizations that have conference rooms that would be available to outside evening meetings, we would love to hear from you. finally, please put your cell phones, tablets, etc. on stun mode. So, Marty, you don't interrupt Marty. For that, I'll turn it over.
Thanks. All right. Let's see if I can do this.
You know,
One. Hey, look at that. All right. So, first of all, thank you very much. I'm very excited to be able to speak to you guys tonight. There's a lot of members from an IDesign Architects Masters class here. I'm excited in particular about tonight because I'm finally getting the opportunity to start presenting and sharing some of the stuff that I've been doing over the past 5 to 7 years with WCF and building distributed systems. And so what I'll show you, I guarantee you will be able to do yourself. Shockingly little amount of code, but it's all about the experiences that I've had and finding the little sweet spots to simplify the experience of using WCF. So just as a quick show of hands, how many of you have used WCF or tried to use WCF? Okay. How many of you love the configuration? Of course, yeah. Well, let's put it this way. You love the fact of how configurable it is, but the act of actually configuring it and maintaining it is a disaster. So we're going to focus on that in particular. Just a little bit about me. I am a master software architect with IDesign. So I build, like, this is what we do for a living. I help clients develop their architectural practice. I help them design their systems, and in particular, and one of the reasons why I joined IDesign is that IDesign is a roll your sleeves up architectural firm. It's not ivory tower architecture. We roll our sleeves up, we are in the trenches, we know how to pound the keyboard, you know, the whole thing, you know, from the SDLCs you'll see, you know, and we also have our own methodology. We're going to hint at that methodology. Some of you are familiar with it. The people who are taking the course right now haven't seen it yet, but I'm just going to hint a little bit because it's kind of key. Certain aspects are key to what I'm going to present tonight. I've built a whole bunch of stuff, put it into production. That's the key thing. My blood's on the floor. The motivation behind what you're going to see comes directly out of the fact of my experiences. I also, you know, speak it, do that kind of stuff. I write articles. I have somewhat of a satirical, acerbic writing style, kind of a little gonzo, like HST, if anyone knows who that is. Some of the old guys may know who Hunter S. Thompson is. And I'm active in my local community, and I think that's absolutely crucial. If you want to develop your career, if you want to be an architect, I tell all of my architects, no matter where they're at around the world, you have to get out in the community. You can't sit in a little bubble and think, you know, that you're doing great stuff until you put it out into the public and you test it. So that's what I'm doing tonight. So I'm very excited about what I have to present to you. And just to get some business out of the way, because I have a lot to do, and if I put this at the end, I may not get to it. There's a AMC in March, and for those of you who know, these things sell out months and months in advance, but we're able to actually give a little bit of discount to everyone who's here if they want to sign up and see Beth Siren in the back. So if you're interested in how a modern software architect actually practices and what it takes to be an architect, and completely catapulting your career, it's a great opportunity. And I'm teaching a WCF masterclass in Chicago in November. And there's also our new project design masterclass, which project design is like the secret sauce. Yeah, so you've got a design, now what, right? You've got something on what you want to build, but where are the instructions on how to build it and how to manage cost, schedule, and most importantly, which everyone has no way of handling risk. How do you quantify risk? So if you're interested in that, come to the Project Design Masterclass, and always hit iDesign.net if you're curious to see the whole list of classes. So what we're going to look at this evening, we're going to explore why the title is absolutely true. You know, so I try to pick a provocative title. I know everyone in the .NET stack, there's questions involving WCF. What do you do? What do you don't do? Where do you put it? What's its future? That kind of thing. There's some very interesting industry trends that we're going to look at, and you can draw your own conclusions. I'm going to show you, based on what I'm seeing in the industry, a new way to look at WCF. A little bit of elbow grease, but with a very little bit amount of code, you can get something cooking that has, if you're familiar with it, something like a service stack simplicity of programming experience. Anyone using service stack? Do you guys, you know, does anyone know, have you at least read about it? You know what it is? Right. It's what's the primary thing? There's one key thing we're going to talk about at length that they have out of the gate. You know, you start with a very simplistic programming model because there's one thing that they provide.
Well, we're using it mainly for ORM Lite.
Ah, okay. So you're not using it as it's connectivity stuff. No. But we'll talk about. There's one word there's one key thing that's missing, and what we're going to get to then is we're going to show the key features, the key aspects of what we're seeing in these trends in the industry, how to apply those to WCF to get a really sweet programming model, and then my favorite thing, which has been my work over the last 5 or so years, extending that to craft a service-oriented programming model. Because that's really what we need. So, and you know, you guys can draw your own conclusions. So first, there's the word. Service stack is so simple because they start with a convention. And then, you know, so there's a simplistic programming model that you begin with for the connectivity stack. And then under the covers, if you need to, then you get into the, you know, the expansive and potentially horrifying larger picture underneath. But at least it starts simple, right? So that's actually the one thing that WCF is missing. You get hit upside the head, straight out, with all the complexity and everything all at once, and then you're left trying to figure out exactly how to manage it. And what you're going to see tonight, the original motivation was that I was chief software architect presented with a very large initiative, service-oriented initiative, and even the senior devs, and this was way back in the betas in 2007, in the early betas of WCF, the senior devs who were, you know, expert developers on, you know, what they had been doing in the past couldn't get a simple example to connect. And so I'm like, wow, if these guys, if we can't get this to happen, this is going to be a disaster, because I had, you know, 15 teams, 100 devs, like this whole thing, this giant initiative, and I'm like, I don't even know, we're not going to be able to get it done. So we had to figure that out. Has anyone had that experience with WCF? Wow, so everyone else who used WCF right out of the box, the very first time you got it to connect and everything was golden, I don't believe you. Sorry, guys. I don't believe it. So, for those of you who are familiar with WCF, you know what I'm going to show you. Does this look familiar?
Oh, yeah.
Does that look familiar? Does that look familiar? A little of that too, maybe? So, client-side configuration, server-side configuration, proxies, service knobs, goo and knobs, knobs and goo, you know, to get it all right every single time, you get one knob wrong and you're foobarred. What I'm going to show you is this. Notice there's something suspiciously missing. That's the point. There is no service system.service model section at all. Now, I'll show you this. Sometimes you need a concrete proxy, sometimes you don't. If you're testing and you're mocking the client side, then you got a factory going on. And we'll touch on that later. Right now, I'm just keeping it simple. So, first, why would I even want to do this in the first place, right? WCF is dead, Monty. It's all REST. It's all raw HTTP. Really? How many people believe that? No one. Wow, you guys are diehards.
I believed it
So-
before today.
Well, yeah, everyone in the AMC has heard the litany from your wall that WCF is about web services and not about a superior programming model for distributed systems. It's all about web services. But what I love about this is not my opinion. This is just my observation. You can draw your own conclusions, but what the entire industry is doing, not just .NET, every stack. Now, I'll only draw, there's just too many to comment on, but I'll show you a few examples, and you can draw your own conclusions. We'll also challenge your notions a little bit about what you should do, and then we'll spend, hopefully, most of the time talking about taking all these things, these lessons learned, and simplified aspects for service orientation and creating a programming model from it. So, look out in the industry, what's going on? This is what we see. Everything convention-driven, simple connectivity, multiple routing modes. That's a little esoteric. That's more relevant to the web stack than anything else, but you can do it in almost all the stacks that we're going to talk about. The big one that's bolded is the key. Multiple transports. If raw HTTP is so spectacular, why is that a trend? Lightweight hosting, that's a huge trend. And even in the Microsoft camp, right, with Owen and everything else, ASP.NET is experiencing a renaissance, an extraordinary renaissance that's just going to, between that and Roslyn, I mean, how cool is it to have a compiler that you can extend? That's just wacky stuff. Now, what are you going to do? What can I? We can write I can write a compiler for WCF. That's actually really good. I should write that down. And then finally, the last one is the thing that I add in there because from my own experience, that for distributed systems is the crucial thing that you absolutely need. Notice it doesn't say unit testing. It says integration test enabled. And that's one thing that none of the other stacks, like out of the box, provide. So let's take a look. We mentioned Service Stack. I like to use this because it's their design is a fantastic reference. If you want to see an alternate approach on how to build a connectivity stack, Service Stack rocks. So what we're going to do is we're going to take each one of the aspects that we can see in the trends, and then we're just going to say, do they have it, and how much of it do they have? So it's yes, it's convention-driven, absolutely. That's why you can take a junior dev with Service Stack, and the first time out of the box, they can get it to work. Now, as he mentioned, Service Stack has evolved far beyond. It started out just as a connectivity stack, and now it's evolved into much more of a programming platform where they're using a particular ORM out of it without all the other stuff, which is kind of cool. But the one thing that we can see is that it started out with raw HTTP, and then sometime soon after, why? You have to question the rationale. Message queuing. Very next thing, right? If you look at their wish list, because it's open source, there's one of the, it's up in the upper higher numbers of requests for sockets. And there's even requests for IPC. Now they have lightweight hosting. They have a little bit of an integration test capability, but not too much. Zero MQ, just as another example. Convention-driven, simple connectivity. They have multiple routing modes. They also have multiple transports. This is a little complicated the way they do that. They have very lightweight hosting. That's like their key thing. It's really a true kind of node-to-node queuing technology. No integration testing. Node is my favorite. They have convention, simple connectivity. There's some manual things here for this. They have all kinds of different transports. They actually have 2 different modes of IPC, which is kind of interesting. And extremely lightweight hosting. You know, that's another key. No integration testing. Anyone doing Node? Yeah. I'm waiting to have the opportunity to do an IDesign method-informed vertical slice on Node using these techniques. So if anyone beats me to it, share your code. So there's a whole bunch of honorable mentions. All this stuff, RabbitMQ, more or less some of the things. AMQP, this, which one I can never tell them apart. This is Web API, I think, and that's SignalR, and this is the service bus. You know, so they all have different levels of these aspects that we're looking at. And so just something real quick, queuing in the browser. It might be something cool that we need something in the future. I'm just thinking. So there's this confluence of thought. Convention-driven, right? Try to make the initial experience easy, and for the general day-to-day, you know, reduce the friction of the developers. Provide some defaults, programmatic extensions to some degree. Provide a simple connectivity story. Most of them all, the only thing you have to set is a base address. You know, and that's just like the simple beginning point. And then from there, you know, you have different connectivity modes if you want to. But at the end of the day, there's just one thing to set. There's some internal routing that can happen, and there's even implied transports for some of the modes. So just real quick on multiple routing modes. There's, you know, obviously you can route by action, you can route by message type, you can route by verb. You know, some of them even have both declarative and programmatic expressions of that, right? So you can do your own, you know, you think of Web API with the routing capability, and you can use the standard out of the box, or you can customize it out the wazoo. You can, and then they added attributes, you know, so now you can have attributed routing if you want. And so across the stacks, you know, that's another trend that's happening. Multiple transports, message queuing, HTTP, sockets, interprocess, in-proc, which is something we're going to talk about, and WebSockets. Lightweight hosting. Now this is really key, and we're going to talk about that a little bit. But when you want to deploy, you know, you don't want a complicated hosting experience. You want something, you know, you can just throw things there and it just happens. And some of the other stacks, you know, that's exactly the way they work. Talk a little bit about integration testing and why a little bit later. So you think about this, right? And if it was all just raw HTTP, you know, it would have never had this trend moving, particularly with multiple transports. So what's happening? I think it's this. I think people are building on these stacks. People are building larger systems, bigger systems, and as these distributed systems evolve, and I can tell you firsthand, anyone who's built it, and maybe some of you can share that experience, they evolve. It's inevitable. It goes beyond just the vertical web stack. Anyone else have that experience? as their system. Who owns a big distributed system? No one? Really? What's everyone doing? Desktop apps? You got to get up on it. It's a distributed world. The brave new world is out there, right? So this is what I think. The stacks grew up. They needed this broader capability, and so and now all the stacks are, and this just goes on, even to the bigger stacks. Whether you look at WebSphere, whether you look at Java stacks, those kind of things, it's all the same. They're trying to get to this point where they can normalize the connectivity. And so the other thing that you can see is that file-based configuration, no. Endpoint-based, no. REST, big server, no. Unit, not just unit testing, no, not really. So you go out in the industry, you take a look at all these stacks. Why are they moving in the way that they are? And let's learn from it. So someone have a question? So one of the things that we're seeing, of course, and that's where the convention comes from, is you want this simplified programming model, right, for your connectivity. And this supports what I call my 3 A's, where if it's not simple, whether it's your design notation or whether it's your programming model, if they can't absorb it, then they can't adopt it. And if they can't adopt it, then they can't advocate it, and you're done, right? No matter how, you cook it up, it's the most amazing thing in the world, but if it's too complicated for them to grok, you're done. And what do we have right now? Does everyone have a superstar A team of generalizing specialists in their shop? No. What do we have? We have a palpable global talent drought, and you got to make the team you have rock as much as you can make them rock, as productive as possible. So that's what I tell my architects. That's their job. You have a developer community of a wide spectrum of acumen that you are responsible for making productive. You can't just give them WCF. Using the raw WCF will make you sick. So these are some things, just observations from my own clients. So we built a bunch of this stuff. IDesign architects all talk. We don't just write pretty pictures and documents and things like that. We build this stuff. So what's happening, of course, is everyone's into API. No doubt there's a place for raw HTTP. Absolutely. WCF is not the hammer for everything. It was never, and these guys even heard it earlier today who were going to the class, that was never the right model for WCF. It's much better, at least in the .NET stack, that it's someplace else, because that's more appropriate pipeline for raw HTTP, web API, right? But that's not the only thing you have. In fact, the second one, I love to tell, most of the people here probably understand this, but the whole entire infrastructure of the world is built on queuing. Anyone disagree? You can't do the cloud without queuing. The whole entire infrastructure of every single cloud provider is queuing. Your favorite website, when you buy something at Amazon, is queuing. It just looks pretty synchronous, but it's all queued. You can't do reliable, robust, high throughput, scalable systems without queuing. And a lot of the clients are just abandoning HTTP behind the firewall because there are more efficient alternatives. Would anyone disagree with me between using raw HTTP and a socket? Which one's more efficient? Right. But it's not appropriate for that certain boundary, nor is it the programming model appropriate for certain boundaries. We'll talk about that. You've got to use these technologies in their sweet spot. And this is one thing that's come out recently. You just can't start terminating your security at the load balancer anymore. I mean, unless you don't really care. I mean, they're going to eventually sniff it out anyway, but you at least have to give it a fighting chance. So there's other things. Has anyone heard of microservices? Okay. Yeah. It's a discussion in the broader community outside of the .NET bubble, particularly being led by ThoughtWorks. And it's a very interesting approach to service orientation. If you're familiar with the IDesign method and a lot of the techniques that we use for building distributed systems, we have been practicing microservices for over a decade. So it's interesting that now, finally, and what you're going to see tonight is really all about that. That the industry is finally starting to come around towards this train of thought. And we'll talk about this a little bit. Has anyone ever heard that term, the software fractal? Push, of course, and then this thing is the thing I love the most. There is a foundational pattern to all of modern software architecture. Extensible interception-based pipeline. Every single thing has that. It's pretty cool that there's actually a foundational pattern of every single piece of software. Now, the cool thing with WCF is that we get that on both sides of the wire, which is not true in most of the other stacks. So this is a lesson I've learned, and I've seen my clients learn this. I've seen them abandon this behind the firewall in other scenarios. It's completely appropriate in certain circumstances, but not everywhere. It's not pervasive. You cannot build modern software architecture with raw HTTP alone. Yes?
With an extremely narrow focus of building Windows, Azure, Microsoft Azure applications, where the endpoints are REST-based, even for storage, and they have their own queue inside after you connect.
Right.
Would then, for a brand new project, ASP.NET Web API adoption would be preferable over the new WCF that you're going to present?
You'll see. We'll talk about that shortly, actually. So it's not an either-or equation. So, yeah, so what? I don't need all this crap. I got my web API. And that's enough, right? But what happens, and this is my own experience, from the clients and the way these distributed systems evolve. When the business comes to you for any one of these, so as soon as they ask you to do something that you can't just shove it all in the database all at once, or maybe in the cloud, it's cost prohibitive to do it in that fashion. You need a little bit more. Now, the architectures, in Azure that you're describing, it's still, the APIs, of course, are going to all be, and I use the term API, I mean, I don't even call it REST. It's not REST. No one's doing REST. It's all raw HTTP. And I try to make that specific because REST is has a very, very clearly defined specification. Almost everyone is not doing that. And as soon as you put a question mark or an action in there, you're off the reservation. So it's raw. I never use the term REST because almost nothing is REST. OData's, started out REST as an example, and then it got a little squirrely. But let's be clear, it's raw HTTP. That's really what you're doing. So any one of these, asynchronous UX, you're going to have to push. You don't push using REST, right? Anything, any one of these things. Hybrid cloud, you need something more, right? This is the thing that you're trying to shoot for. Absolutely. Business agility. What does that mean? That means that your software assets, you can move them around. Parts are in the cloud, parts are on premises. One day they're here, next day they're there. You can't do that any other way than doing service orientation, period. Everyone agree? Fundamentally, we're all doing service orientation, right? We'll talk about that a little bit later. So these are all the things that I'm seeing just really quick. It's not good these days to deploy all your bits into the DMZ. In fact, maybe you want the DMZ to be super thin, so you get that extra level of separation and an additional security boundary. Reliability, quality of service. These are some of the things that drive the evolution. You need to go beyond the website. A single interaction mode. We'll talk about what I mean by an interaction mode later. I really wish I could tell you there was. But there is not anywhere in the whole entire industry, there is not a happy path magic stack. That means that you go to one magic little place, click, click, double click, everything just goes poof, and it's all there for you. Unfortunately, that is not the story that everyone in the whole entire industry has to deal with right now, right? You have to be, you have to have an understanding of these different stacks, how to piece them together, because they have the technologies appropriate for a given place, and we'll talk about that. Anyone disagree with this? Anyone building on one single thing for everything? Right. So I promised this. Let's look at WCF. Where do we stand out of the box? Not too good of a report card, right? No convention, no simple connectivity. It does this, you know, if you know how to tweak it, you can control routing modes, things like that. This is more of an advanced thing. One thing it does do is this. That was the key thing that they wanted to do with WCF, right? They normalized the connectivity programming model. They got that 100% right. It has a form of lightweight hosting. We'll talk about why it got a caveat, and there's no integration testing whatsoever. So how do we solve this problem? That's really what we're talking about. We look out into the industry. We see these trends. We have a tool in our kit bag that has some support for these. One of the key things is there, right? So how do we leverage it without all the blood on the floor? Now, some of these techniques, nothing here is complicated. It's all vanilla WCF. It's just taking one small layer away, going one layer deeper, and just seeing out of the 32 different extensibility points, which ones are really key. So, does it have a simple programming model? Would anyone say WCF has a simple programming model? No. No. If you can't give it to a junior dev and they can't rock on it day one, that's what you're dealing with. It's not a simple programming model. I hate to use the term, and everyone cringes. And most everything is this. It is an expert technology. Anyone disagree? You need to know what you're doing to get it right. Put it into prod and own it over time. Now, I'm not talking about you playing with WCF. I'm talking about you putting into production a real system with real users over time, multiple versions. Then we can have a discussion, right? So for any technology, that's the same thing. ASP.NET is an expert technology. Web API, regardless of what stack it's on. You know, the programming model may be simple, but when you really need to use it, you need to know what you're doing. Distributed systems are more complicated, period. It's not just wiring everything up to the database anymore. That just doesn't fly. Again, so we must simplify, or you're just going to have problems over and over again, right? So how do we do that? Well, it just so turns out that WCF is, in of itself, a contemporary framework. It just happens to do connectivity really well. They built the extensibility model, then they built WCF on top of it. It has that fundamental pattern, extensible interception-based pipeline that we can exploit. It's also, it has the hallmark of a good framework, it's symmetrical. And so we can leverage those things on both sides of the wire. That's another key thing that simplifies the programming model dramatically. What I'm going to show you, you can absolutely do yourself. This is not black magic kung fu. It's just knowing where to tweak it. So, if we're going to solve the problems that we have, there's things missing. And so, looking at it, there's three key areas. There's the configuration problem that we have to solve. There's the connectivity, the simple connectivity problem that we have to solve. And then somehow we have to simplify that programming model. Because I tell you right now, you do not want every single dev to have to put service behavior attribute on every single service, and then they get to decide how they're going to set the instance mode and connectivity, and the connectivity mode, or the concurrency mode, excuse me. No. That's not what you want. How many of you have created a custom service behavior? Oh, how many of you are using WCF? There were a lot of hands the last time I asked. All right. Configuration. We have an extensibility model. Let's exploit it. The key thing that I've learned from deploying WCF, and I've talked to other architects who are building things on other stacks, this bears out in practice regardless of what stack they're on. The vendor will tell you a different story. It was all in the config file because they thought that you would need to change it all the time, over and over again, every time you deployed it. No. In fact, once you test it and you figure out how the knobs get set, I've asked dozens of architects who have done hundreds of systems since WCF came out, and I asked every single one of them, do you ever change the configuration once it's in prod? No. Really? Then why would you ever put it in the config file? I mean, there are some things you need to tweak, but we'll talk about that. No. Your testing tells you, and your system design, first of all, tells you how the knobs should be set. And it's a powerful thing to have those knobs. It's actually policy. Timeouts are a pain in the ass. They're a powerful tool. So is throttling. So are message sizes. Max array length isn't something you find at 3 o'clock in the morning because some table finally got too big and the devs are pushing too much through one pipe and suddenly the whole thing blows up. No, you know that in load testing because you cranked it down and you established a configuration policy that says we will not have more than 20,000 entries. And if it blows up in test, long before it gets to production, because you don't want that call at 3 o'clock in the morning, you know. And then what you do is you have control over WCF abuse. So the guy saw this today. We've all hinted at it. He didn't go into it too much. It'll be in the new edition of the book. We've crafted an alternative to UDP-based discovery called TCP-based discovery. And in there is this configuration policy. And this is the same. He had some of it in the framework that we worked on. I've been doing this for years. Independently, we kind of gravitated to the exact same configuration policy with WCF. You first establish your defaults programmatically. If nothing needs to change, there are no knobs that you can override either programmatically or through the config file if you have to. All the while, some things are non-negotiable. If you never ever want anyone to ever send more than 20 meg over the wire, you can control that. Now, how powerful is that? It's not a pain in the ass that you have max receive message size. It's a powerful policy tool that you have control over max receive message size. It's a powerful tool. Now we'll talk about how this gets wacky in a second when you start to apply that at a very granular level. Then you're like cooking with plutonium. But, so, anyone ever done a custom channel factory in WCF? Well, the reason this is worthwhile is because of this one little override. You get this one little override by creating a custom channel factory, and now you have complete control over the client-side configuration story. And because it's beautifully symmetrical, it's even named the same on the other side. It's the exact same thing. Except this time, on the service side, you need a custom service behavior. Or, excuse me, custom service host. Now, you only need to override what you need, and the rest you can leave behind. Now, the other thing that you have to do a little elbow grease with some helpers, whatever is relevant in your, how you handle this in your own stack. You got to have control over the binding. Now, the binding this is where you set the binding. That's there's defaults. So you have your default binding, everything set exactly the way you want it. It can be programmatically overridden, and we'll see in a second how it's overridden via the config file. Someone puts a little piece in there, and then you enforce your binding policies. Some things are non-negotiable. So this is the general flow for the configuration policy. Nothing spectacular. You have a binding. If it's been set, you use it. If it hasn't been set, you look in the config. If it's not in the config, you use the default. And then, because they're non-negotiable, after all of that, even if they try to override it, you enforce policies. And if they try to override something that you don't allow, you blow up on them. Nothing ever gets into production that you don't have explicit control over. Period. Ever. Now, this is also compatible with more advanced things like discovery. These guys saw this today. Or if you built your own homegrown configuration service, you can jack this stuff in. It's just a starting point. Now, so we've solved configuration. We now have almost a zero-touch configuration story for WCF using that configuration policy. But we still have this problem of endpoint configuration. How do we get around that? All the other stacks, base address. HTTP stacks, no endpoints. Web API bubbles up through the pipeline, routes. Same metaphor, just no config for that hard endpoint, right? That's the pain point, that hard endpoint. How do we get around that? We have the binding and contract, we're missing the address. So the way that I like to solve, and I've been using this for a long time, so this is really what we're driving at. We just want to start with, we want a really simple configuration story. I don't want to have to add some wacky stuff to the architecture in the beginning, though it's the right way to solve the problem is like discovery or something like that. I want to be able to do it out of the box in test on a dev machine day one. Namespace configuration, or convention, excuse me. And your namespace must be symmetrical. What does that mean? It means that you establish a namespace convention that promotes what you need out of it. Now, this is not the recommended way to do namespaces. I don't really care. The other cool thing about flipping, because usually what happens is you have the subsystem up here, and then it gets more granular, right? That's the recommended best practice. I don't want that. What is one of the core things about service orientation? Reuse. If I'm going to have reuse, I don't want to have to drill down 5 layers to find something that some other subsystem might be able to use. I'm going to flip it around so that I can actually use source control as a service-oriented governance tool. So I can go into source control and go, what proxies do I have? What services do I have? what contracts do I have? And we'll see in a little bit how this becomes really relevant when you apply the IDesign method to it. Then, if you have a taxonomy, you can go into source control and say, how many of these orchestrators do I have? How many of these engines that do atomic work do I have? How many data-related elements do I have? And if your naming gets good in your design, then you can give a team a design. Two teams can have the same naming when they get good at it. They can go to source control, see who started it, and add to it without ever coming to you. Everything that I do is completely self-serving in that I want less people at my door, a smaller queue at my door, and a lighter inbox. My sole motivation is completely selfish. So what we're talking about is this. Now I choose sales because I have an example that's actually a small little use case from a real client, and they're from the point of sale industry. But this is kind of what we're talking about. Now, why is this relevant? Oh, that's not good. JV. So anyway, the trick is that you have symmetry. So you can perform a simple swap. Literally, on the client side, to enforce the endpoint name policy, you just switch substitute service for proxy. Because you have hosted the service at its fully expressed namespace. Service side, oh, excuse me, I had an extra slide, that's what's happening. The service side does contract for service. And you do that because you actually want, the endpoints are contract related, not the name of the service. And that allows you to have multiple contracts per service and all that good stuff. So at the end, you apply that configuration, that little bit of convention. That's the last bit of the endpoint address that you need. Now, of course, they have to provide the base address because you can't glean that without discovery. But that puts you on par with all the other stacks because you have to give them base address too, out of the box. But at least now all you have to do is, if you remember that simplified configuration, all you need at the end of the day is the server name to get started, right? Yes?
For a client that is a Windows 8 store app, are you able to explore the symmetry that you talked about and the simplified configuration from the client side, which is the Windows Store app?
To be honest with you, I would have no idea. I have not done a Windows 8 store app, so I don't know the particulars of that. I know there's many restrictions involved there. Yeah. But to be honest with you, I mean, if you can apply that to your API, I mean, at that point you're really refining your API, right?
Yeah, I was thinking more about, because it's leveraging a lot of the .NET runtime things behind the scenes, and then the .NET runtime on Windows 8 store apps is limited with the, it's a different layer. How much of the WCF stuff is really supported in that runtime? That would, I think, determine whether you can leverage these new things. Well,
to normalize it, I mean, we'll talk about this in a little bit, but you use the technology in its sweet spot. So almost everything out to the client is API these days, right? You use raw HTTP, not WCF.
Yeah, but it would be nice to leverage this new WCF and simplify in a new brand new Windows to make, because not just like you say raw HTTP, if you got queuing and other things on from the Windows Store app, it will be really nice to leverage this.
Yeah, that's something I'd have to look into. I'm not sure that model would work for that restricted platform, right?
Sure.
So now, just real quick, you can still extend this to support, more involved, advanced scenarios for hosting. So the idea that we're going with now, so we have configuration. We've solved connectivity now. We have this, by a little bit of convention, we've dramatically simplified the connectivity story. Now how do we solve the programming model? We want a really friction-free, day-to-day programming experience for the devs, right? We want them to be able to just fall right into the pit of success and get building on both sides of the wire. And so we're still missing, sorry for the feedback, we're still missing the scheme from the whole connectivity equation as well. So what we're going to do is, the way I've solved this, I call it something, an interaction mode. Which basically means you normalize binding, behavior, extensibility, policy on both sides of the wire into a consistent programming model. And that's where the scheme comes from, the last bit that we need. So on the client side, again, custom channel factory for our configuration story. We have a simple little proxy base. No auto-generated proxies. No, no, no. Why? Because that's the extensibility point. We want to jack into that extensible interception-based pipeline that's on both sides of the wire. And the way you do that in WCF, you do a little bit of a custom proxy base with your custom channel factory. And this is just showing an example of some of the stuff you would do. You know, again, this stuff is all really specific to your needs within your domain. But you know, you can have your default sitting here. We of course enforce the endpoint name. We enforce the standard address. It's just a way of combining the base address along with the endpoint name, and then it provides a binding, creating the factory, creating the address. On the service side, you need just a little bit more, but each one of these things is really tweaked only lightly. Custom service host, like we saw, service behavior, and an operation behavior. And in this particular example that I'll show you, the operation behavior is not even used. It's an extensibility point for future need. And I throw in here that you should only have one custom service behavior, because having this giant stack at the top of your service is just not what you want. So you have a custom behavior, you can wrap that all into one single attribute. So again, on the custom service host, we have these things. We can enforce policy here. We have our opportunity to control the configuration, all with just a little bit of code. You just need to know the right place to extend. This is showing the custom service behavior. There's really nothing going on other than implementing the standard iService behavior interface, enforcing our policy at the right spot. And here's where we ratchet it down so that everyone uses the same policy all the time. Best practice per call, multiple, and no, we don't want it to suddenly sniff out the synchronization context, because then it's single-threaded and that's a disaster. In tests, that can make you pull your hair out. Someone puts the open in the wrong spot, suddenly your test host is single-threaded and you're trying to do load testing and it's blowing up all over the place. Just turn it off. Unless you need it, of course. Operation, this is what I'm just showing. This is the placeholder where you jack in through the custom operation behavior for your invoker, which is the last extensibility point on the service side before WCF calls your actual operation. So you can get in there and do all kinds of cool stuff right before it gets into the hands of the dev. Now, what does this provide? Well, we'll show the interaction mode first, and we'll talk about it later. But you can imagine, once you have an extensible interception-based pipeline, you can do a style of aspect-oriented programming. Jack it all under the covers. Devs never know it's there. You can evolve it. Their programming model never changes, and they don't have to have all that boilerplate all over the place. Powerful stuff. So then, this is literally the code for an intranet proxy base. We're going to define an intranet interaction mode. And what intranet? What's the best binding in WCF for intranet? Net.tcp. Same thing for the behavior. That's it. And this is really just a little bit of the host, showing that what we're going to do is we're just using our internet binding, and we're applying some of our policy for every single contract on that service by default. Now, of course, you can evolve that when you want with your own conventions. What this is also showing is that we're checking the config file first, and if someone's overridden it, we're going to use that. So now this gets us all the way down here. Real quick, we'll take a look at lightweight hosting and integration testing. So WCF has self-hosting. That's really sweet, lightweight model for hosting. That's all I've ever done. I have tens of thousands of Windows services hosting WCF that never crash, ever. There's only one thing that I've ever seen anyone ever crash an actual WCF process, and that was mixing WCF threads with .NET threading. And they had blew up the .NET thread, and if you blow up the .NET thread, WCF's there not to protect you. And what happened? So you may have organizational policy that requires you to host an IIS, but lightweight hosting is the way the industry's moving. It's incredibly convenient. Most of the times I've never had an issue with ops, because they don't like IIS either, for services, right? And they're so used to deploying Windows services, they have it all automated, so it was never ever an issue. I don't know, how many of you guys are hosting in IIS, and anyone using self-hosting? Everyone's using a little of both. Yeah, at this stage, particularly if you have an API, you need an IIS, right? So the new stuff coming is going to really help with that. It's going to be, the story for IIS in the future is going to be as lightweight as that, which I think is phenomenal. I can't wait. So just real quick, host helper. It does a scan. You can have your IOC do your scan instead. It detects the interaction mode that's applied to the service and hosts it appropriately. So you don't need anything in the server-side configuration. Yes?
Can we go? I want to go back to the hosting thing. What was the whole deal with WAS, and is it dead, or what's all of that about?
Yeah, I honestly don't know. I mean, it's there. It was the way that they could inject the other transports into the IIS pipeline, right? They had to have something, and then they used that as a hosting model in general. I think it's going to still be there, but
was it trying to simulate IIS hosting without IIS overhead, or was
it's the Windows activation service. So they actually used it for HTTP as well, but you could host it by itself for the non-HTTP related transports. But it was always so grafted tightly together with IIS that it almost felt like you were installing IIS anyway. So where that lands with the new stuff, that's actually something I'm not quite sure about there. Yes?
Do you have a best practice for logging errors when it's self-hosted like this?
Yes, and we'll see that in a second.
Okay.
So this is really a simple host helper. All it does is it initializes, which means it goes out, and again, it leverages the namespace convention. Goes out, looks at the binaries, looks for the namespace convention, goes inside, looks for the appropriate taxonomy names, looks for the appropriate one that's actually the public interface, and hosts it. And that's it. And now there's this little extra thing for launching. This is the way that the start looks. So it just orchestrates these things and then calls launch at the end. And then this is your one-liner for hosting. That works in IIS. That works in Windows Service or in Xeon. So this is the kind of simplified testing experience that you want your devs to have.
Sorry, you said that works in IIS, you said? Is that what you just said? Did I mishear you?
I'm trying to remember the last time.
Because this is not an IIS, right? That's running as an EXE.
Yeah, but you can use this same thing. There's a little bit more goo that you have to do for loading them up. You have to have the auto start on, that kind of thing. So you can get them loaded up, before the first request comes in.
Can you go back on the first slide, please? So if you have multiple services you want to launch, you can do it, right? I missed that part probably.
Yeah, so basically what it's doing is it's leveraging the namespace convention.
Right.
It's scanning. It's doing a little scan. Now, whether of course, you wouldn't do the scan yourself. You probably have your IOC do it. But you leverage the convention in your scan, and you hint the IOC to load up your services. And then and along with the interaction mode, now you know that it's an intranet service because you have the intranet behavior that's associated with the intranet service host, and you just start it up. Okay, real quick, integration testing. Why? The test experts will even admit, with even 100% coverage, you will only catch 30% of your bugs. The remaining 70% are integration. So if you had a limited budget and only a handful of developers, what should they be banging on? Putting the stuff together. But putting the stuff together, you have to put the whole stack, So you want this kind of thing. What does it mean? What is unit? Unit testing doesn't mean that it's always granular. That's just one scope of a unit. If you go out in the rest of the world where they actually do, unit under test testing, the unit under test grows as the previous ones go, the lower levels turn green. It doesn't always stay that granular. That's why it's called a spiral. You think of a corkscrew, at the very bottom is unit testing. Unit testing's good, turn it once. Now you involve more. That stuff's good, you turn it again. Involve more. Turn it again, involve more, turn it again. You go up to the top, test the whole thing on the service side. You've tested all those things on the client side. Then you turn it again and you bring the two together and test. Then you turn it again and you put the whole thing in the lab and beat the shit out of it. I never put anything into production until I have all benchmarks. I love nothing better than the smell of fresh metrics in the morning. Absolutely. I'm a firm believer. Continuous integration, you should have continuous load testing. You get a little lab, you get a guy who's really good at that stuff, he runs the lab, you got a rig. At a certain point, when you get enough code that's critical mass, you just beat it up every day until you release. It's a distributed system. That's the whole point. And some of the guys were talking to me about this before. We've lost this. This is lost on most of the devs today. They look at something, they think it's going to be super efficient. Yeah, on your desktop with one user, sure. You don't make any decisions until you've broken it. Then we can have a discussion. It's a distributed system. We build these servers that runs on a server. It runs on a server because it's going to hit high, it's going to be beat up. Almost all these systems, they have a breaking point. You have to know that. And it's really good. My favorite testing tool is VSTS. You get these reports out of it. And those are a really powerful thing to have in your back pocket. And then I know every single day, if it blows up, then you know why. How many of you guys are doing continual load testing? You gotta do it, man. And it's not expensive. Tools are free. Set up some VMs, commodity VM. You don't need anything big. You want to run it on one, because that's the cool thing about service orientation is what? Its scalability is linear. Test one, get the benchmarks, then you know how many you'll need for 10,000. You don't need a big rig. Now, that's just a general, of course, there's unique systems that don't have that behavior, but by and large, service-oriented distributed systems scale linearly, right? So, how do you get this more granular integration testing without the pain? Because what does it mean? You got to set up the stuff all the time. You got to put the mountain of bits up all the time, right? Not true. What you want to do is mock the service environment. How do you mock the service environment? You got to make it look like you've got the whole thing going, but it's running in the test environment, in the unit test environment. So there's no need for a proxy, separate host processes, wire up, config, all that stuff. And then you can use your standard unit testing tools to run multiple levels of the spiral of test. So you have something like this that allows you to inject the method into the mocked service environment for execution. So it looks nothing more than this. And the test method looks nothing more than that. And just to show that there isn't scary goo in mocking the service environment, this is the code. And I'll show you guys this running in a second. Now the key here is this little guy. This is Yuval's original technique for creating an in-proc service that you can download from iDesign's website in Service Model EX. And if you have Service Model EX and you haven't looked at that, shame on you, because it is the future. It's been in the book since the very first version, and he's completely right, and it's happening slowly. All the trends are leading towards it, and we'll talk about that hopefully if I have enough time. So all this is doing, now, there's a little bit of reflective goo here. I'm grabbing the generic definition here because this is very time consuming. So you grab it once because it never changes for a given method in proc factory. And then I'm creating, because we got I, who is changing, the generic instance of this method, and then I'm just invoking it. What this code does in proc factory, which I didn't put in here, I think it's later. But all it really does, what it does internally is extraordinarily simple. But it's the combination of the way, the insight on doing it in the first place that's the powerful thing. And so that's a really cool thing with WCF, self-hosting. So you can just spin up a service in process, create the host, create the channel, wire them together, et voila, in proc service. Very simple. So that last piece gives us everything. So this is actually a few lines more. 393 lines of code for the convention essentials. It gives you this. So just to recap real quick, we've learned a bunch of things from the industry. A few key extension points in the framework. Industry recognized set of core aspects. Let's see it. Anyone have any questions?
Are we going to get these slides?
Yeah, I can share these slides with you. All right, it's going to be hard doing it this way. Let me change this. No questions?
when you're setting up this test harness in real environments, are you actually accessing? I mean, is that project that is the test harness application referencing the code directly, or are you loading binaries to get the services? That makes sense, because you're running multiple services within one process in order to do in-process integration testing, right? Or did I miss something?
I'm running multiple services.
Is it you're just running one service at a time? You're running. Aren't you doing integration testing in progress? I thought that was the whole point of it.
Yes.
So you're integration testing, so you're running multiple services, and they're interacting with.
Maybe we'll look at that. It would be a shame if I had all this and I couldn't make some of them mocks, make some of them real, and control all that, so I could test real stuff with mocks and mocks with real stuff, and turn that spiral, right?
Right.
I started them all mocks. I started making some mocks and some not mocks. But that's what you want. You want that granularity of testing, right? Right. Yeah. So the answer to your question is, it depends. So, real quick. Nothing up my sleeve here. Nothing up my sleeve here. My wonderful client test harness. Bang. Service. Testing. This is actually more interesting. So I'm just using this. Most people use NUnit, but since it's already integrated, my examples, I like to keep the dependencies to a minimum. So what we have, this little guy does nothing but inherit from the unit test base. The unit test base is exactly what I showed you. It has some extra goo in here from examples from the past, the things you can do during integration testing if you need to. 3 lines of code to mock the service environment. You should also be able to test your services as POCOs. It's important. And then this is the integration test in the test environment. So we set it all up, get into our simulation. No host, no config, no proxy, no wire, no nothing. Pretty cool. Any questions?
Can these be automated in your build process?
Of course. It's already in the tool. If they can automate it and it's already in here, that's kind of the key takeaway from this, is that you get this higher level of integration testing into the tool that they can automate, whatever it is. And then you can do, we'll see why this is so important in a little bit. But all right, are you guys good? Because that was good stuff. You still with me? Because now this is the secret sauce. This is the juicy part. So, involves the original form edition of the book, the future, intro to service orientation, the last section, the future. What's coming next? What does he call for? You've all read the book. You should know it like the back of your hand. What does he call for at the end of the Appendix A?
What's on the screen there?
No, he doesn't. He calls for a service-oriented platform.
Everything is a service?
Well, a service-oriented platform would enable that. We don't have a platform yet. However, someone just built something really soon, and the Halo team rocked on it. You guys should know all about this, and you guys should understand the actor model and how profound it is. It is the original design pattern in our industry. period. And shockingly, it's having a resurgence 50 years later. Get to know the actor model. The definition of the actor model sounds strangely familiar to anyone who's done service orientation. Active objects that are concurrent, that communicate via immutable messages. I'm just saying, I want that on-prem. I want Orleans on my laptop. But until we can have that, the best thing we can do is a programming model. We can't build a platform. It takes a giant organization at this point like Amazon, Google, Microsoft to build it. And they will build it. And we will rock on it. But until then, we can do this on your laptop. So I've noticed that there's two things, real quick. I'm going to try to blow through this, but there's two parts to the programming model. There's connectivity and design. And the crucial thing is that you can apply this to any connectivity stack. We already saw the core aspects. So now you have this list that you can start looking for. Any stack, Node, Web API, anything. You can start looking for these things and how to exploit it. We're going to simply use WCF as a reference stack. And it just so happens that because of the way they designed WCF, it might be the easiest one to express all this stuff on. So of course we have this notion of an interaction mode. Another takeaway here, just like your configuration is informed by your system design, not your deployment, the interaction mode is also based on your system design, not your deployment. You're not your topology. And most likely, from my experience, now your mileage may vary, in theory, you were supposed to be able to change these. Oh, maybe one day I'll do WS HTTP finding, and the next day I'll do MSNQ, and the next day it'll be .tcp. No. It never changes. There's a reason for that. So why not wrap it up? So we take the notion of an interaction mode and apply it to every single interaction in the system. And these are the 5 most common ones that I've seen that you need to build modern software architecture with. API, I use as a general term for RAHDP. You need this to signal on, you need to be able to push. This is where the comment, there is no happy path magic stack comes from, because you can't get all the things you need from one technology. It just isn't happening today. No matter where in the entire industry is doing this, there is not one stack that has everything yet. So we just take our core aspects and apply them to all the interaction modes. So you have that little bit of code, the key extensibility points in WCF, and you do it for all of them. It's not a lot of code. And the benefit you get out of it is astronomical. These guys heard today, you've all walked through kind of a hypothetical quantification of the programming productivity benefit of something like WCF in comparison to having to do it yourself. You know, it's like 1,000-fold. I think it was even more than that. So you imagine, you know, if you've got to build, you know, for the back end and you need to do services and you get all the goo out of the way, you want those developers focused on producing business value, not WCF. And in fact, their day-to-day, it shouldn't even exist. Now, I'm not saying that they shouldn't master it, and they shouldn't look at your infrastructure and dive to the bottom of it. That's also an indication on who might be an architect apprentice, who are the guys you might want to groom, the guys who are coming to you with questions on your infrastructure, and the guys you want in your foxhole. So we're just going to heed our lessons learned. We're going to leverage the extensible pipeline. that also provides us a form of aspect-oriented programming because we can jack it in underneath and no one ever knows on both sides of the wire. We're going to establish a connectivity policy across all the interaction modes that normalizes connectivity. So the programming model is exactly the same. That's the one key thing that they did with WCF. It's literally the same. You're doing queuing and it's the same. You're doing TCP and it's the same. You're doing HTTP and it's the same. You're doing in-proc. I mean, how that's profound how they pulled that off. You know, and there's other examples in other stacks that they do the same thing. And the last bullet is key. We want to apply the technologies in their sweet spot. Whether it's for reach, whether it's for quality aspects, you know, all the ilities, or their programming model. The programming model is key because the dudes, the angle bracket dudes out in the browser are talking and coding using certain tools, and they can rock on that all day long, the raw HTTP interactions and Angular and everything else. You give that to a back-end dude, not so much. Anyone in the back-end really wants to rock on interfaces. Now, there's trends moving both ways, but by and large in the industry, that's the way it plays out. So you want to get a programming model in their hands that they can be most productive with. And we already talked about that. Some of this is not WCF. It's not a magic wand for everything. So it's also interesting to note you can start applying these interaction modes at certain boundaries. Now, from the design perspective, this is key, because you can't just arbitrarily make things services. There's a notion in design that when you're going to design something like this, you need some guiding metaphors. And those guiding metaphors keep you on the right track and ensure that you're, you know, when you come to a difficult decision, that you'll make them consistently. Conceptual integrity when you're designing something like this is key. So one of them is something we call the message is the application. Another is a spin on Yuval's hyperbole of every class is a service, but more practically, because we don't have a platform, we only have a programming model. I use the term component. It's way overloaded, but you get the gist, and we'll talk about that, what a component really is. So services are nothing but a clever ruse, right? There is no service. In modern distributed systems, there's a message. Every operation is a message. It just happens to pop out in the class. You can deal with that message, you can deal with a simple programming model, but there is a message on the wire all the time. They might have a long life. They may lead an interesting life. It may eventually want to go home, or not. However, the system dynamics should be able to influence the message without corrupting it. The best way to influence that is to inject metadata into the message out of band. Messages may transmute as they move through the system, but their metadata stays with them. Metadata can aggregate throughout the message's lifetime. You should think of messages as immutable, but their message metadata may not be. But you think to consumers, the metadata is immutable. But to the infrastructure, it's not. You want to really control how this stuff works. The message's contextual relevance is essential for the system to understand and interpret the message. And we'll talk about what that means. Try to get through this real quick. So the best way to do that, you make your metadata contextually relevant. So the message drives the system, creates continuity across the whole entire thing. You can think of it as like a logical thread across the whole entire system. Where it's been, where it's going, where it came from, what it wants to be when it grows up. And the key here is that you don't want your contextually relevant metadata in with your DTOs. You don't want to mix that. The DTOs are for the business information. Most of the time, your context is for the system. And they have two separate axes of volatility, which basically means they'll change with different pressures to the system. And when you couple things together that have different axes of volatility, what does that mean? Every time one changes, it's change both of them. That's pain. You don't want to do that, ever. That's why it's better not to jack them into your DTOs, like in some base class or something like that, and flow them out of bank. Now, what do I mean? This is just another observation. That if you can get away with it, if your stack supports it, it's ideal if they're expressed as classes and objects, WCF as data contracts, and not as just key value pairs. So here's some examples from live systems. Session context. My favorite thing for a session ID is a string that's human readable, that has the machine name, the PID, the process name, and some other goo. So I can look at it and be like, that is the originator of this message throughout all time, the life of this logical continuity across the entire system. Here's, for those of you in the class, one take at solving the problem of the Heisenberg uncertainty principle with the logger. This has worked out extraordinarily well, where we give up on ever having a continuity of time across all space in the universe, and instead, what I found was most relevant to the people who are going to be looking at these logs, customer support. When did it happen on the client? So when did they hit a button on the client? And then you store that, and between the client's timestamp, which is now part of the context for all time, no server time, no time zone crap, no nothing, and the sequence number that we increment at every single point, you get the true sequence across the whole entire universe. And so we didn't need the time everywhere. We really needed, okay, when did this thing start at the originator? That's how we can tie it into what they were doing, you know. And then the sequence shows us, you still put the server time in there, but you don't use it as the primary organizational aspect. That's worked out really well for me. Here's another one from the point of sale. This is live context. Excuse me. Some stuff in there. These are context specific. Now, when I say context, you know, it's relevant to your domain. Mobile is a context. The big website is a context. You want to differentiate between them. You want to know who the originator is. You want to carry that with the message across the entire system. Now, to do this, it needs to be bidirectional. Yeah, Pat?
Would you say that the environment context, you only need one of those per system that has everything that system's business cares about?
Well, you look at these, and these are specializations for, you know, this system had a retail side, had a back office side, and had an online side. You know, so, but they had the core aspects of the environment, but they needed to be tweaked for each specific context. The key here is that it's bidirectional. You can't do tracing without it being bidirectional. That means that you get it in and you put it back. You copy them from one to the next, and this is how you keep that logical thread of continuity across the message. Even though messages are immutable, it comes into a service, gets transmuted into a new message, gets sent out to a queue, you make sure its context goes with it. Now, of course, no boilerplate. You don't want to do something like this. Aspect-oriented programming, you put it under the covers. And this gets done under the covers all the time. The service or the infrastructure is contextually aware. So some things are custom, like the environment context you saw. Some things are common standard context that are ubiquitous the entire system. So this is what you want. Just like we have ambient context already in WCF and have always had in .NET, and you will have in Java and other platforms, we want to use the same exact programming model, relevant to your domain. So all you really do is have a service base, have the getters, and it pulls it right out of the message. Key is on both sides of the wire, of course, from end to end. And we'll show if you guys are willing to hang out. We have to be out of here at 9. You guys all right?
Yes.
This shows the header helpers. This is the key. No one should ever have to do this. The devs don't do this. However, they may need to, as your system evolves, you may need to evolve, like add new standard contexts. So there's a little helper that's jacked in to the extensibility flow, and I just add them here, 2 spots, and we're done. And these get called at the right spot in the chain, flow them throughout the whole entire system across all the interaction modes. You add it when they don't exist. You copy it to when it's going out. You copy it from when it's coming back. You do that through another extensibility point, the message interceptors. So you have one for the proxy, handles your standard message flow, context flow, and then one on the service side. So you leverage iClient message inspector and iDispatch message inspector. Do the same exact thing. Again, the symmetry in the framework reveals the profound beauty of its design. It's exactly the same. Link is incredibly symmetrical. It is an incredibly powerful thing that you can do with Link for any provider that you have. So as an example. So you can use this now, the infrastructure uses the common contexts, and you can inform operation invocation, fault management, instance provisioning, all kinds of cool stuff. Again, domain specific, based on the context. But traditionally, the message flow stops at the public boundary. How do we extend the goodness? And how far do you go when you increase your service granularity? Opaque, big, giant God service, not so good. Object level, it's too bad Alan left. I've been waiting for this. I'll have to show it to him. Is that the appropriate level? Probably not. Component, some ambiguous term of a component, maybe.
Alan doesn't like that either.
Whoa. At this level now, I can actually put a boundary around it and be like, yeah, I think I can do something with that. And then I can do this. And then I can do that. And that's the software fractal. Now, for those of you who know the method, why are the lines for the big thing dotted? It's a notational representation.
It's a Q.
It's a Q. This is the true expression of microservices. And they're just starting in their conversations to realize that you can't do across separate process boundaries. You should be doing this instead of synchronous. Modern software architecture. Ubiquitous message flow from the top to the bottom, across the whole entire universe. Now I don't really, I said design component level. We'll get back to that. That's why it's in italics. But this opened up, of course, this huge new powerful capability. Greater control, AOP, throughout. It actually promotes solid. You get ubiquitous message throw across all boundaries, layers, components, the whole thing, top, bottom, all the time, for everybody. Great control. Isolation boundaries are key. Now you have a more granular application of an isolation boundary. Also, the opportunity, like I said, you got all these knobs. They're powerful. You can put a timeout on a given component. You can put a different configuration policy at a component level. This particular component has a smaller max receive message size and 3-second timeout. You do not know. They are not thorns in your side. Those things are powerful capabilities, along with all this other stuff. Not least of mentioning security, fault management. And you get this AOP capability under the covers, where now you can start doing message inspection and invocation control, fault management. These are some other aspects, just 1 or 2 more extensibility points. It's like 2 lines of code. End-to-end logging, which will show you the trace context flow across a whole bunch of different stuff. And I think the most important thing is this. When you need to drive consistency, repeatability, and sustainability in your dev shop, crank it up. It also promotes solid because it is an explicit interface programming model. Solid is opt-in. Contracts are not. You have to have an interface. That doesn't mean you're going to factor it right, but at least it's a start. You can't do it any other way. However, we already saw this with the testing. Traditional approaches to this just mean more configuration, an explosion of config, an explosion of hosts, endpoints, proxies, and you go more granular, right? Inefficient interactions, potentially increased coupling. So how do we solve that? We want to automate these things. We want to get rid of all of them. We leverage this. So here's literally just very little code. Get service model EX. Take a look at it. The key, the most efficient interaction that you can do between components and still have a message, name pipes. So you can see now why I'm jonesing to do this in Node, because it has all of it.
Hey, Monty?
Yeah.
If that's the code that's being used, how are message headers flowing into the services that Brock Factory's hosting?
Oh, you will see.
Oh, okay. So it's outside of Brock Factory.
No, actually, it's easy enough to jack that in there. It's you throw the proxy. Well, you'll see. There's the server side's already taken care of, so you just inject the service behaviors on either side. And this is all the code for the essential code for hosting the thing. So on one side you get a channel back, and on the other side you get a host. Add the service endpoint, and you're ready to go. And you guys can get this code, take a look at it. There's nothing complicated at all. It's all standard WCF. So this is where I don't like the design component comment. What is our unit of reuse? Is it the object? I don't like calling it an object because there's stigma associated to the granularity of objects that I think is inappropriate. And you have this to contend with. Anyone disagree? Service orientation is not object orientation. And if you try to apply the techniques of object orientation, service orientation, it actually leads you into anti-patterns. It's interesting that solid still applies. Uncle Bob got it right back in 1994. Smalltalk got it right back in 1972. Active objects with immutable messages. The active model is in your future. So at this point, I don't use the term SOA anymore. It's just service orientation. It's a new programming paradigm with its own rules, stuff like this. You have to apply it differently. Pitfalls, everything. You need a taxonomy, though. So to solve this problem, you can't just arbitrarily make anything a service. You need some rationale on what to make a service and what not to make a service. That's where a taxonomy comes in. And each component should ideally have a role, responsibilities, and a set of rules that define its interaction. And so that's where I would say more appropriately, instead of design component level for the appropriate level of granularity, it's the role, the component role. Now, design, of course, for those of you who know, have a methodology that has an incredibly simple taxonomy. It only has 3 components. It's like the blues. With 3 chords, you can create an infinite number of blues tunes. And we've been doing this you've always been doing this for longer than even WCF existed, and no one's really ever come up with the need to add another one. So you can create a system of arbitrary complexity with 3 roles. Now, I don't have time to get into what that means, and the guys who are taking the class will get a boatload of that later in the week. But we can apply our namespace convention to it, and then this is the use case that we'll actually look at. Now, just know that each one of these has a specific role, a specific responsibility, and roles of engagement. And so with all this, you can have a programming model that looks like this. This is that use case. So assignment manager, usually we read these things from left to right. Call comes in, assignment manager first calls environment data access, then it calls the association engine, which then calls the rules data access. So we should see that explicitly expressed in our use case, orchestrated. So we create the service, we make the get environment call, we get the details to then pass, to inject into our engine. The engine then uses those to get the rules, pass the environment back. And just so you know, just like mock service environment, that there's no scary kung fu. Excuse me. Create service does the exact same thing. What this is showing you is the flow of the context. Comes out of the client, into the manager, into the engine, back out, back into the engine, back down to the data access, and back up. We're also going to show this, and we're going to show that. Actually, what we're going to show is this to back to the, so it's going to be, if we have time, if you guys are willing, we'll express it in service bus with a queue interaction that jacks into a topic interaction from auditing to events. So it does all of this flowing over 3 different queues. So what do we have? We have a normalized connectivity model across all the interaction modes with an appropriate service granularity that's informed by a taxonomy that enables ubiquitous message flow across the whole entire system with ambient context at every single level and formal isolation and policy boundaries on every single thing. And it supports all these existing aspects that we already identified that the industry is driving towards. So, one last thing real quick. I'll just jump to this. This so what this is is that one diagram that I showed you with the bus, this existing use case. So if we look at notice the namespace laid out. This is the same, which it'll then audit. It goes over a queue, which auditing will then fire an event. Excuse me. We'll take a look at this stuff flows throughout. It'll fire an event, which is actually a topic. I'll just spin it all up. So you can do it to each one. Of course, it's a system, or you can do it first to the SOA. This is a very common pattern where you go synchronous first into the back end that facilitates a synchronous background activity across multiple subsystems that can potentially eventually go all the way back to the client. So we're in a sign environment, just like we saw a little while ago. So it goes through the engine and has actually touched the context in a couple places. We do audit proxy, which if we take a look at real quick, there's our same programming model for Service Bus Queue.
Monty?
Yes?
Can I give you just a heads up on the time?
Yep.
Thank you.
We're done. So we get in here, and the relevant thing is this. So from the client across to first the administrative or association manager through multiple components that actually touch the trace context, and we can see the original session context has flowed from net.tcp through IPC back out into the queue and now into this environment, and then finally again same thing here through the topic with the sequence number having been modified. Yeah, so, and the code for this, again, exactly what you saw, just applied across every single interaction mode. So we have intranet, queue, topic, subscription, improv.
Will this reference code be available on the iDesign site?
Not quite yet. It's not ready for publication, but it soon will be.
Can you talk a little bit about that? What's the intent?
You're welcome. The intent? Intent of?
Just describe how we can do all this. Is this like instructions we go off and do this, or?
Yeah. So the key here is that, you know, and of course this code will eventually be made available so you can use it as a reference. The key here, though, what I've found, and I use these techniques for all of my clients, is that it's really domain-informed infrastructure. It's not generic. So what you need, you take what you need and you leave the rest behind. You don't do all these things if you don't need them. Most of the systems evolve to need these things. You know,
creating domain-specific conventions, et cetera, and so forth, to give us all those different characteristics of the frameworks.
Exactly. So,
but it's context specific, as you say.
Yes.
And we, as the architects, come up with that for them.
Yeah. And so now you can apply it to the technology, simplify the programming model, boost, you know, productivity. The key is that flow, the realization in modern software architecture that you're going to have that flow of context across the whole thing, and that it's valuable to have that logical thread of continuity that any point when that message arrives someplace, the system can react to it. So it drives the system.
Yeah, and we're doing all this with WCF out of the box as we know it today.
Yes.
We're not waiting for some brand new, yeah.
No, you can do it in 4.0. So the key here is just identifying out of the 32 extensibility points, there's only a handful that really you can leverage to make this happen with a little bit of elbow grease. It's not a lot of code at all. The key is identifying that, in fact, the configuration does not change largely when you deploy, unlike what the expectation was and why you had giant monstrous config files in the first place, and that the interaction modes don't change either. You know what I mean? And so you can wrap these things up and provide this really simple programming model on both sides of the wire. So, sorry I ran long, but hopefully you found some value from it. I'm really excited about being able to present this to you guys. And feel free, Monty at IDesign.net, ping me with questions. If you try it, let me know.
You have Twitter?
Not yet.
Oh.
Yeah, I'm a Luddite kind of. I like to be
Productive? Still.
What's that? Productive. Yeah, I'm not on Facebook either. So what do you think? Try it. It's very easy to do.
Download your sample code?
So you said it's...
Unfortunately, it's not ready. Not quite yet. No, it's not part of Silver Model EX right now. And honestly, like I was telling him, that it's more about the aspects. Because you take what you need and you leave the rest behind. In your domain, you may not need only half of this. But it's those things that, those core aspects we're even seeing industry drive towards. Wrapping up, establishing the configuration policy, and where just 4 or 5 points in the extensibility model where you jack in with a handful of code. Apply your own policy for enforcement, set the knobs the way you need to set them. So that's where it's really not a generalized framework approach. It's the techniques you can use to make that service-oriented programming model.
Did you mention when the new book is due out, or?
Thank you for reminding me.
Well, we answered the last questions. Let's already start a little exercise that everyone who brought some trash in takes it with him and brings it to the trash to help us to be fast out of the room because we have a hot cutout at night.
Yeah. So the 4th edition should be out sometime early next year. Thanks, guys. Thank you.